Hello, so in this particular video I am going to tell you how we can solve this question number 14. This is 14 from this book Engineering Circuit Analysis by Hayt, Kemmerly and Derwin. Right, so it is the question number 14 in chapter 5. So in this circuit what we need to plot a graph between IL and VL. So this is VL, this is IL, corresponding to the range of R from 0 to infinity. So this range, this R value is changing from 0 to infinity, and then we need to plot a graph. So to solve this type of a circuit, first of all we need to write the expression between of the IL and VL. So if we determine the IL, so simply IL is the voltage divided by total resistance. Since 5 kilo ohm and this R, they are in series, so simply 5000 plus R. 5 kilo ohm, so I put 5000, right? And our VL, it will be IL into R, right? Now for this our simply we can draw a graph, draw a table where we can change the value of R, IL and V, right? Now if let the unit for current, let it be in milliampere, and for the voltage VL, let it be voltage. Now if I take resistance as 0, then I will get IL as 3 upon 5000. It means 0.6 milliampere, right? And corresponding to this formula, VL equals to IL into R. So since IL is 0.6, R is 0, so our VL will be 0 volt, right? Now if I take R as, let me take it as 1000, so it will be 3 upon 5000 plus 1000, so it will be 3 upon 6 milliampere, right? Or we can simply write 0.5, right? Unit already I have mentioned over there. Now corresponding to this, I will write the VL later on. So if I take R as 2500, then this will become 5000 plus 2500, and solving this we will get the value as 0.4. Similarly, if I take R as 5000, then R will be 0.3. If I take R as 10,000, then it will be 0.2. If it is 25,000, then R is 0.1. And if R is, say, infinity, if R is infinity, then it will be 3 upon 5000 plus R, which is infinity. So it means 3 upon infinity, which is equals to 0, right? So you can see by for different value of R, it start when R is 0, the initial value is 0.6, and slowly it becomes 0. Now corresponding to this IL, using this formula IL into R, we can get our VL is 0.5 into 1000, so it is 0.5. Remember, 0.5 is in milliampere, so 0.5 milliampere into 1000, it will be 5. Okay, 0.5, it is milliampere, so 10 power minus 3 into 1000. So this 1000 and this is going to cancel out, so we get simply 0.5, right? Similarly for this 0.4 into 25 into 10 power minus 3, right? So it will be this, it will be 1000 into 10 power minus 3, so we get 1. Similarly, we will get for this 5,000 we will get 1.5 volt. For 10,000 we will get 2 volt. For 25,000 we will get 2.5 volt. And for infinity, now for infinity our like expression, it is IL into R, right? What is our IL? It is 3 upon 5,000 plus R into this R. So it is this. So our V, it is equals to 3R upon 5,000. So over here we need to apply the limits. V is equals to limits R tends to infinity, right? And it is 3R upon 5,000 plus R. Now, as per the limits fundamentals, if we take R as common from both up and down, so it is 3, and this denominator it will be 5,000 divided by R plus 1, right? So this R and this R is going to cancel out, right? And now substituting the value of this infinity, we will get 3 upon 5,000 upon infinity plus 1. Now this term, it will become 0. So we get 3 upon 0 plus 1. So it is 3. So it means the voltage for infinity case, the voltage will be 3, right? Now having these values of IL and VL, now easily we can draw the graph between IL and VL. Right now IL is starting from like it is 0 to 0.6. So we can have a scale like 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. And at 0.6 the voltage is 0 volt. At 3, like at 0 current, voltage is 3. So 1, 2, 3. So at 0 current, voltage is 3. So simply if we join this, if we plot all the points, like if we 0.5 is 0.5, so it will be somewhere over here, right? Then 0.4 and 1, so 0.4, 1 over here, right? 0.3, 1.5, so 0.3, 1.5, 0.2, 2, so 0.2, and then 0.1, 2.5, right? So we get a straight line, and this is the answer to this particular question, where we need to represent IL and represent a graph between IL and VL. So if you have any doubt, you can put it in a comment box.